operational hours. In this slide, we are going to go into details about diversity factor, which is another important factor in a power station. So maximum demands of every consumer type. Uh, the types can be residential, commercial, industrial, consumer. They are just a few types. There are many other types as well. The maximum demands of these consumer types do not come at the same time. For example, a residential consumer may have a maximum demand around 6 p.m. when people go back to home and perform their like when your father and your mother come back to home and they perform their home chores and they use electrical appliances for that. So around 6 p.m. It is expected, especially in Egypt where both male and females work. So in Egypt especially, this is the case that around 6 p.m. the maximum demand occurs. So the residential consumers have their own maximum demand and the time for which that on which that demand occurs on the power system. Then the commercial consumers, they may have different maximum demands, and their maximum demands may come at different times. Their demands may even overlap with the residential consumers, but that is a thing we will discuss in QA sessions in detail. And so the industrial consumers, they have the highest demands, and their demands usually come in the morning from 9 a.m. to 5 p.m. With a maximum demand occurring around noon. So the maximum demands of each type of consumer come at different times. So the diversity factor is defined as the ratio of sum of individual maximum demands of these types of consumers divided by the maximum demand which occurred on the station. So that maximum demand which occurs on the station may not be the demand of any one particular set of consumer. You may have the sum of maximum demands of consumers as the maximum demand of residential consumers plus maximum demands of industrial consumers plus maximum demand of commercial consumers. But when you divide it with the maximum demand on this which has occurred on the station, that maximum demand which occurred on the station may not necessarily be the maximum demand of one of these individual consumers. That maximum demand which occurs on the station may be the sum of some demands or maybe an entirely different demand. So that gives you the diversity factor. So let's take some observations from this formula. So observation 1 is that diversity factor is always greater than 1. Obviously, because sum of individual maximum demands will always be greater than the maximum demand which occurs on the station. So, and in this observation, there is another point that higher values of diversity factor mean lower and cheaper electricity. So high diversity factor implies less maximum demand, allowing lower installed plant capacity, thereby resulting in lower capital cost and cheaper electricity. That is the second observation, and I'm going to explain this observation piece by piece. So high diversity factor, number 1, means that sum of individual maximum demands is very high as compared to maximum demand on the station. So what you say is that this power station with this diversity factor is able to cater to a wider variety of consumers with a smaller maximum demand. And this smaller maximum demands means that you have to install less equipment in the plant, less generating equipment in the plant, so the plant capacity can be decreased. And when plant capacity decreases, then the capital costs decrease, and the running costs also decrease, and the electricity cost becomes low. So it doesn't matter how large the sum of various categories of users on power station is. All that matters is how large is the maximum demand of the station during any given time period. So the point of this, the point of this bullet point is that it doesn't matter how large the sum of various demands is, because what matters for your power station is that it has to meet the maximum demand which occurs on it. So regardless of how many types of consumers are connected to it, it must be able to cater to the maximum load demand which occurs on the power station. So if diversity factor is large, it means that the plant is able to cater to that area with a wider variety of consumers, which is a good thing. So if numerator is much larger than denominator, it only numerator means this a top term and denominator means this bottom term. So if numerator is much larger than the denominator, it only means that the nature of loading in an area, nature of loads in the area permits us to serve a large variety of consumers. So the the way in which loads occur in that area permit us to serve a wide variety of consumers with relatively less installed capacity, which is a desirable trait. So this is the significance of the diversity factor. In this slide, diversity factor is explained. So let's take a look at this. So there are three consumers which are connected to a distribution transformer which is shown here, and the distribution transformer is being fed by a line which is commonly known as feeder. And this feeder comes into the distribution transformer, and then this distribution transformer which serves various consumers. So distribution transformers are normally located in your outside your homes, and they are normally one distribution transformer is sufficient to serve 50 households. So 50 normally 50 consumers share a distribution transformer, but that is not a generalized rule. So that can vary. But you are being the consumer. This distribution transformer steps down the voltage from 11 kilovolt, which is the voltage of this line, this line which is coming from the grid station, to 230 or 400 volts based on the or even 11 kilo no to 230 and 400 volts for the residential consumers, which are you guys. So each consumer may have different maximum demand, and that may occur at different times of the day. For each household may if there are for example, if there are 50 households, then 10 of those households may have a different pattern of usage, then 20 may have different pattern of usage, then 20 more will have different patterns of usage. So these, based on these patterns of usage, you can categorize the houses, and their maximum demands will occur at different times of the day. So that is how different categories are made. So maximum demand on the distribution transformer is less than the sum of these maximum demands. So the maximum demand on the distribution transformer will obviously be less than the sum of all these demands of the different types of the consumers. Similarly, maximum demand of multiple distribution transformers, like the distribution transformers fed by different feeders, they will be different from the maximum demand on the substation to which they are connected. So the feeder, normally feeder, but grid station is also called, its second name is substation, or you can say that substation's second name is grid station. So from a grid station, various feeders are emanating, and these feeders carry power to the distribution transformers serving different areas. So the distribution transformers may have their own maximum demands, but the sum and their sum of and the maximum demand which occurs on the grid may be different from them. So that the diversity factor of the grid will obviously be different than the diversity factor of the distribution transformer. So in general, we can say that higher diversity factor means that you can generate lower cost electricity. This is the exercise which I have given you guys to solidify your concept on how average load can be calculated from daily load curves. So you have to compute the average load in this daily from this shown daily load curve. You have to show all of the steps in your work. So you have to obviously segment this graph because you do not know the equation of this curve. So you need to segment the graph into multiple rectangular sections. Obviously your calculated average load will only be an approximation, so you will have to create segments and then add up the segments and divide by the number of the segments. So attempt this, and if there are any problems, you can ask me in the designated QA session. Now we are going to talk about plant capacity and plant use factors. Plant capacity factor is defined as the ratio of actual energy which is produced by the plant in any given time period divided by the maximum to the maximum energy which it could produce during that given time period. So actual energy which the plant produced during any given period can be represented as the average load which occurred during that period multiplied by the total period itself, while the maximum energy which could have been produced during that given period can be calculated by multiplying the plant capacity, installed capacity or nameplate capacity of the plant by the total period itself. So plant capacity factor can also be, in this case, the plant, if you cancel these time periods, then plant capacity factor can also be taken to be the ratio of average load or average demand to the plant capacity of your plant. You should keep in mind that your plant capacity is always greater than the maximum demand which the plant has to cater. In the practical scenarios, plant capacity is always kept higher than the maximum demand which the plant has to carry, because some capacity is reserved for extraordinary circumstances, like when a load increases beyond the specified limits for a portion of time. Your plant should be able to provide that power. Annual plant capacity factor is defined as the annual kilowatt hour output of the plant, or kilowatt hours generated per annum, divided by the installed capacity of the plant multiplied by the total number of hours in a year. So this plant capacity factor gives no consideration to the plants, that for how many hours that plant was in operation and for how many hours was that plant shut down. The plant capacity factor is only uh, is represents the plant performance throughout the years, considering all the time of the year. Power stations are designed with capacity greater than the maximum demand to meet future loads. Obviously, future loads may increase in the future, so they must be able to provide those loads. So power stations are usually designed with a capacity that is higher than the maximum demand. Plant capacity factor is an indication of reserve plant capacity as well. So reserve plant capacity can be found by plant capacity factor. If you know the average load, you know the plant capacity factor, then you can find out the installed capacity. If you have maximum demand or load factor as well, then you can find the reserve capacity from this formula, which is plant capacity minus maximum demand. So plant use factor is defined as the station kilowatt hour output. So the kilowatt hour of the plant power station divided by the installed capacity of the power station multiplied by the number of hours for which that station was in operation. So plant use factor does take into consideration that plant may need to be shut down for maintenance purposes. Let us talk about importance of daily load curve. So number one is load curve shows load variations on power system during different hours of a day. So it gives you information, a graphical, a pictorial representation, so that you are better able to understand that. So area under the daily load curve gives the number of units generated in that day. So whatever the load curve is, you take the area under that load curve, that will give you the energy generated in the day. So number of units of energy generated in that day. Highest point on the daily load curve represents the maximum demand on station on that day. So maximum demand on the station on a day is represented by the highest point on the daily load curve. Area under the daily load curve divided by the total number of hours gives average load on the station in a day. So if you have area under the load curve, you divide it by the total number of hours, so you will get the average load on a station in a day. Ratio of area under the load curve to the area of rectangle in which this profile is contained gives the load factor. So I'm going to explain that in a bit on the diagram. So we can get the load factor or plant capacity factor even from the daily load curve. How we can do that, I'll just show you in a bit. So this helps in selecting the size and number of generating units, obviously, and it helps in preparing the operation schedule for the station. So let us look at this daily load curve. This is exercise 2 for you, by the way. So what you will do is the rectangular section in which the load curve is contained can be found if you create a rectangle on the maximum demand of the station. So from this maximum demand, which is 6 megawatt for this load curve, you create a horizontal line. So the area in this rectangle, which I am pointing to here, is the total area of that rectangle, and the area under the load curve is the area under this curve. You divide this area by the area of this rectangle and you get the load factor. However, say your maximum demand is 6 megawatt in this case, your installed capacity of the plant may not be 6 megawatt, it may be even 8 megawatts, or it may be 7 megawatts. If you consider that plant capacity and you draw a rectangle which encases this load profile, but it is slightly higher than the maximum demand of showing the reserve capacity of the plant as well, then if you take the ratio of this area of the rectangle and this area contained in this curve, then you'll get the plant capacity factor. So, but this exercise only focuses on solidifying your concepts about the load factor. So what you have to do is you have to compute the load factor from the shown daily load curve, show all the steps of your work. You have to perform similar segmentation of this curve, or you can use the previous results from exercise 1, and you have to divide those results by the area, divide the total energy generated, which is the area under this curve, by the area under the 6 megawatt line. So you will get the load factor. So calculate that load factor from this pictorial representation. Now let us talk briefly about the types of load which can occur in a power station. So these types of loads are number one, you can get domestic loads, which include lights, fans, refrigerators, heaters, television sets, small motors for pumping water, etc. These are categorized as domestic loads, which are present inside any consumer premises. So residential consumer premises. So these have very low load factors. So these domestic loads have very low load factors, which tells you that the average load from the domestic sectors at any given time is way less than the maximum demand. So the load factor of the maximum demand which can happen in a residential sector during the day can be may be high, but the average load which occurs uh, which uh, uh, which is sent by that residential sector during the day will be very less as compared to that maximum demand. So load factor of these loads is very low, so they are one categories or one type of loads. Then there are commercial loads. They are same as domestic loads. They same as domestic loads mean they also include lights, fans, even refrigerators and heaters and television sets, and even some small motors for pumping water. But they occur for more hours than domestic load, and their load factor obviously is slightly higher. Then there are industrial loads. Obviously, unlike domestic, they will be high. And unlike domestic and commercial loads, these loads are high and not weather dependent. So your domestic loads may be weather dependent, but industrial loads are not weather dependent, because regardless of the weather, you have to create products. So your machinery may be working even in all the weathers. So industrial loads are not weather dependent. Municipal loads are other form of loads. They include street lighting and power required for water supply and drainage, pumping operations for water. You have seen even if you live in a residential sector of Islamabad. Normally, water from Wasa is delivered to your residence at night around 10 p.m. So the pumping operations are generally carried out at off-peak times to balance the load factor of the power system. So then we move on to irrigation loads. They include motors to supply water to fields, and they usually supply water to the fields during night, because as we all know that it is better to give water to plants at night than during the day. Then there are traction loads, and traction loads are those vehicles which run on electric power from the power supply. So they may include electric vehicles, they may include tram cars, trolley buses, railways, which are electric railways, which are even present in India as well. And I don't think we have some similar system in Pakistan, but in India there are instances of electric railways as well. So these loads are high during morning and evening when people are using these electric vehicles, but at other times they are normal, but they have wide variations. Obviously, when more people are loaded onto a bus, it will draw more power from supply, and if suddenly someone steps out of that bus, then the power supply will be affected. So these are different types of loads.